Krigh Bachmann is a technology consultant specializing in the design, construction, and operations of the built environment. With expertise in both established and emerging technologies, he excels at translating complex concepts into practical, real-world solutions. Krigh's portfolio includes work in digital delivery, contract language, generative artificial intelligence, BIM, smart buildings, prefab construction, and digital twins. Throughout his 20-year career, Krigh has collaborated with various companies, including renowned practices Dialogue, Gensler, and Polar Thomas Edwards, to integrate these cutting-edge technologies into their processes. He has also consulted building owners on developing robust digital information requirements and remains an active member of Toronto's building intelligence community. Krigh frequently shares his insights at industry events such as Autodesk University, BuildX, Built NA, Building Transformations, and TBIMC. Did I pronounce that right? Okay, good. Okay, so welcome Krigh to the stage. Thank you.
Okay. Thank you very much. Okay. So, so buzzwords. We love them, we hate them. We want to embrace them to show that we're staying progressively ahead. Yet at the same time, their definitions sometimes muddle what we're actually talking about. So what I like to focus on here is the concepts behind what these buzzwords are about and to understand them and how to apply them. Just as a quick introduction, I'm Krigh Bachmann. I've come from a design background. I've got 20 years of experience, and as was mentioned, I've worked with large different design practices and different organizations, and I've spent 8 years in the UK as well, learning all about some of the stuff that you heard in previous talks as well, such as BIM Level 2. But the main way that I describe myself is I'm a leader of digital innovation. And what is that? Well, it's just another buzzword as well in our industry. Basically, what it means is I work with industry professionals to understand the technology and how then to translate it and practically apply it. So dig in deep, understand it, bring it back, and make it real. So today we're going to be focusing on a few of the key big buzzwords out there. Some of these we've been talking about for a while. Some of them are, much more hotter topics. But what I want to do is sort of dig into these things and sort of talk about them. But then I want to focus on specifically how I'm seeing within the research that I do, some of the connections between them and how I think that they're influencing and starting to sort of accelerate each other. Now let's start with AI. And yes, I know it's the big buzzword of today, but really, the other thing that we have to acknowledge is the fact that AI is actually nothing new. It's been around since the 1950s, and it's been slowly developing. So why has it become suddenly this hot topic that everybody is talking about at conferences and featuring and everything like that? And I think that it's because you have to kind of take a step back and say, okay, well, yes, we've been working with AI for a while, but what we haven't been working with is machine learning. And machine learning is the newer aspect of artificial intelligence. It is a subset of AI. And specifically, if we were to talk about the differences between this, I think that our industry gets very confused. It's the buzzword, everybody's talking about it, but there's two different aspects of AI when you come to talk about it. There's sort of the traditional programming. Let's think about something as simple as, before we get into our industry, a dog detector, okay? If you wanted to design a dog detector, you'd have to tell the computer, this is what a dog is. It's this size, it's this shape, it's this, this is what it looks like. So you have to define the rules and you have to give it then the data, images of dogs, and then it will come up with the answers of, is this a dog, yes or no? However, machine learning, on the other hand, is something different. You give it the rules, so the data, you give it lots and lots of images, and then you tell it which ones are dogs and which ones are not. So the idea of it is that a traditional programming, if you give it an image of a dog and it says dog, and then you give it an image of a cat and it says says dog, you have to then go back and say, no, this is a cat, and you have to redefine it. Whereas machine learning goes through and learns that process. So you basically give it lots of stuff, you instruct it on how to learn from that stuff, you repeat that again and again, and you eventually train that model. So when we hear about things like ChatGPT, Midjourney, DALL-E, these AIs that are starting to emerge, it's because they've been trained to do that. Then you take that model and you then apply it and put it out there. For example, then you start to use it and you use it for more purposes. And if you think that this is an easy task when it comes to dog detection, try the blueberry muffin versus the chihuahua. But what about design? Let's bring this back to practicality of what's happening in our industry. Can AI design? Can machine learning design? Well, in theory, if you gave it enough designs and told it this is different designs and this is the different aspects of it, could it learn that? Could you actually train a model to design? And yes, in some ways it can, much the way humans can. It's absorbing knowledge, and this is exactly what image generation such as DALL-E or Midjourney do, is they basically have been taking tons and tons of publicly available images or image libraries and digesting it, and therefore you're training the model to be able to design. And can you get results out of it? Yes, you can. You can tell it right now, and one of my favorite ones to test these things out with is a modern house built on the edge of a waterfall. And this has come up with a design. We may not have had much influence in it. It was a pretty easy statement. There's not much put into it. But the reality of it is that it actually is designing. So in some ways, yes, AI is starting to be used in this way in design. But the other way that it's starting to be used is for coming up with concepts, and I think this is much more practical because the modern house, we don't really have much control over the process. We're just getting an image, it's nice, it's good to show. But the real power is when you're trying to start to look at this, and we've looked at examples where you're trying to explain a concept, like a patient room where it's looking out onto an atrium that's filled with a zoo. This is a concept that, okay, yes, the reality is we maybe would never actually design this, but if you're trying to convey this concept across to somebody that's an owner and operator that's hired you to design a building, this conveys that idea. So it's taking concepts that are hard to relate to and to be able to produce them as a visual element. Now, that's the machine learning side of things, but I think the other side of things is we keep batting around this AI and buzzword that suddenly got so much attention because of things like ChatGPT and the image generation, but the reality is that we have the other side of things, the traditional algorithmic approach. Things like TestFit and other programs, this is just one example of where it can design, and it's doing it computationally. It's all just hard calculations. There is no machine learning involved necessarily in this because all it's doing is when you remove one of the buildings, it's infilling and it's managing to do it. And these programs are getting more powerful and they're getting smarter and they're getting much more, their abilities are growing. So what we have to recognize is that while the machine learning side of things is emerged and is coming out, you've also got this side of things. And it doesn't just apply to building layouts. We've got groups like Layout where I have seen this done as a live demonstration on the screen where they took an empty floor plate and they want test fits for how, for what can fit in layout-wise for an office. And it may not meet code, it may not be the most beautiful design, but I used to know somebody who did this for a full-time job, and this program can do it that quickly. So these programs are growing and becoming much more powerful. If you're interested in hearing about Augmenta, it's not just on the design side of things of architecture and interiors, but from the electrical standpoint, as well as they're looking at tackling mechanically and electrically. This is a Toronto startup that is speaking at Building Transformations later, where they're looking at doing conduit runs and being able to put the endpoints and the panels and being able to find the most efficient runs. This is hard calculations, but it's creating efficiency and becoming much more accessible. So when we think about where this is going, I think the important thing to understand about this is that there's these two sides of it. And what's really going to become much more powerful is understanding what's going to happen when these things start to come together. When you actually start to say, create a layout for an office that fits this area, similar to the last 5 projects that we did with this client in the Western region. This is something that can only really happen when you actually start to combine those two different sides of things. So although we're talking a lot about AI right now in our industry, we're really seeing it as one or the other, and that you're starting to see a blending of these things, or as we start to apply more machine learning and then getting it to be able to calculate and create those designs using computation. So the generative design or computational design that we've been hearing about for years, combining with that generative AI. Now, with this, AI needs data. Just some of the facts. GPT-4 costs $100 million. Adobe Firefly took the entire Adobe stock library to create. Or the fact that Stable Diffusion, which is another AI tool that I'll talk about in a second, took 5 billion text-image pairs to be able to train. So this stuff isn't going to be necessarily easy for the everyday person to create. With that in mind, we've started to see certain things start to emerge on that side of things. This was a group that I met earlier in the year, born out of the AIA Large Firm Roundtable. The Innovation Design Consortium is a group that is made up of 39 large practices from the AIA. One of their goals is actually to create a common library that they can actually train AI off of. So it's interesting to see different things emerging within our industry, because this is also one of those things that we have to recognize the fact that, well, you can't just, yes, okay, a modern house built on the edge of waterfall, because there are tons of images of modern houses out there. But our designs within our design practices and within the construction side of things and owners and operators, that's not publicly available data that's easily to get your hands on and train a model on. So understanding how this is going to emerge or how that emerges as it moves forward will be interesting to see. Now, with that, I have joined different industry groups online where you hear about architects taking some of these models. And yes, okay, Stable Diffusion was a trained model, so it's an image generator. But they're now looking at how do they take those and adapt them and retrain them. So the idea that could you take this and give it specifically a subset of just your data and say, I want you to generate images based off of these. So this is the sort of thing that we're going to start to see more of, is models that are trained by large organizations, but then can be edited and tweaked for your specific needs. The other side of things is the whole interaction with the tools. It's the fact that you've got things such as I'm sure most of you have interacted with Copilot or ChatGPT. It's a large language model that you can just talk to. So why can't our tools become like this? One of the things that I know that our industry struggles with is the fact that we're constantly getting new tools that we need to learn, and we have to learn these processes, and they're very sometimes technical. I know a lot of people that went to school for design. They didn't go to school to use computer software, right? But that's where they have to go in order to use the tools. But as the tools become more human, this was an example by Hypar where they sort of theorized, could you actually get it so you can describe what you're looking for? A building that is 100 feet or 75 feet by 100 feet, and it's got this many floors, and the image is actually, or the software actually generates it for you. Or things like Evolve Labs, who created Glyph, which was their Copilot tool, where it said, can you add dimensions to these elevations? I think that as these tools become, as these little large language models and trained natural language text chatbots start to implement, and we heard about that in some of the other tools that we heard about in previous presentations, the tools are going to become easier to implement because the fact that you can use them on a regular basis by just talking to them as opposed to learning those new points. So when it comes to AI, I think the important thing to understand about them is the fact that there's a lot of people that come up to me and ask me, okay, so is AI going to take my job? I think the reality of it is we have to stop thinking about AI as this daunting, fearful force, and more about the fact that our mobile phones have a ton of AI built into them. And what we can do standing on a street corner today versus 30 years ago is incredible. But we don't sit there and go, my mobile phone is trying to take my job, right? We have to embrace the change that comes with these tools and think about them moving forward. And it can be a little bit interesting because there aren't many technologies that we use the word intelligence with, but this is one of them. Of course, there's also building intelligence. And what do I mean by building intelligence? Well, I want to pivot for a second and move away from AI and talk about smart buildings, prop tech, building automation systems 2.0. Okay? So another big trend that I've started to see is that within the buildings, and I know this will sound a little bit different, it's not quite design focused, but the operations of buildings. A lot more technology is going into our buildings. A lot more data sources are going into it. And a lot more users want to be able to interact with the different systems in that building. And the way they do that is by connecting and using different systems within that built environment. So things like balancing the energy load might involve connecting multiple systems to the grid and being able to monitor that, or being able to understand different occupancy by different user groups. And right now, the traditional system or the traditional approach is a very siloed system. When I started getting into understanding smart buildings, because I started digging into digital twins, and it's very similar, and I'll talk about that. I came across the Nexus Labs, and James Dice, who took this photo, came up with some really good material for understanding this. But I think if I was to put together a definition, we can sort of define what a smart building is, but it's basically, the simplest way is it does things better than a dumb building, right? But really what you're trying to do is create efficiency and effective or economical use of resources. So you're trying to create better experiences, you're trying to create efficiency, and you're trying to participate in the bigger environment through sustainable initiatives. And so with all of these things combining, we're trying to do better things with our buildings. So the traditional siloed approach doesn't work because you've got multiple systems doing similar things, and you can't leverage the data from each one. So as James Dice, as I recommend, check out his blog and his podcast, but he described it this way and sort of saying, so what people are doing is trying to overlay point solutions on top. But then you get into even more complexity. And really what the industry is trying to move towards is much more of what he described as an independent data layer and horizontal architecture. The idea that could you create a building that combines all these different systems so that it aggregates how it's being operated into one central data store, and then being able to leverage the different applications on top of that. But that level of integration does not happen if you take a traditional approach. What do I mean by that? Well, for starters, it's the fact that you've got different disciplines involved. So from a design perspective, we've got mechanical, electrical, architectural. We coordinate those things, but who is actually looking at that experience? If you think about what does it take to design a intelligent building, a smart building, whatever you want to call it, and how do you get it integrated? I've seen projects where we're bringing on what's called a master systems integrator, or an MSI, late in the process to try to create that integration, but is it being thought of early enough in that design process? So the points that I'm highlighting here as missing is that integration within the design process. MSIs and master systems integration is coming along, but feeding that into smart buildings really has to be done right by digital strategy up front. And with that, and I'll talk about in a moment, comes a feedback loop. So specifically talking about these in a little bit more detail, I believe that there will be much stronger emergence of a new discipline. And this is something that's kind of happened on projects up till now, is that we have smart buildings consultants or intelligent integration happening, or perhaps it's being handled under mechanical and electrical as part of the design process. But the thing that I think is different about this is two aspects. Number one, it's spanning across all the different disciplines. So it's not an individual discipline. It's about something that actually coordinates across it. Think about this in the way of sustainability. So right now, if you want a sustainable building, you can change the shape, the envelope, the way the occupants move through it, the different systems inside it. All of that requires an integrated approach across everything. So much in the way of sustainability consultants have now become established within our industry. I believe that this is something that will become much more prevalent as a regular role on our projects as an integration specialist. And you can see that within the different groups that do engineering in our industry and design. And what I find interesting about this is that the groups that I featured up here are not necessarily always seen in our industry, are not practices that are smart buildings only. These are different engineering groups, different design practices, but they've added that integration level within their practice and their service offering. And I think that that speaks to the evolution that's happening, is that within our industry, a lot more projects are featuring this, and it's almost starting to be seen as a regular occurrence within projects. Within this, I've also seen that the community is thirsty for knowledge, but thirsty to learn from each other. I'm part of a building intelligence group that meets up in Toronto, and as part of this, you can see by the different groups involved that there's owners and operators and different consultants and technology providers. But what's interesting about it is that everybody that comes to the table is very interested in openly sharing what they're doing and be able to learn from each other. I think that this is one of those things that the group understands, that we need to continue to evolve this and move it forward. So with this, we're also not the only organization. Obviously, Building Transformations has also the different think tanks that have been focused on this as well. I think that it speaks a lot to the openness and desire within the industry to continue to evolve this side of things. The other piece that I want to mention, and it was brought up by some of the speakers before me, is ESG, and specifically environmental social governance. For those who haven't heard the term as much, the thing that caught me about this was the fact that, yes, we know that these are important goals for different organizations, but what's really interesting to see is what's happening also when it comes to these under goals that are being put out by different organizations. So as an example, if you are a publicly traded company in the United States that has set your goals of, we want to be zero carbon by 2050, well, it's nice to be able to say that, but how are you actually doing it? And so what is now happening is that the SEC is requiring people to disclose their progress on their ESG goals. And so with this, well, you can't actually move ahead unless you're actually creating efficiency. And to create that efficiency, you need to measure. And so a lot of this comes down to there's a lot of talk within the smart buildings communities about needing to be able to fully understand what's happening within our buildings to be able to actually decarbonize them properly. We've seen similar moves in the EU, and there's been a little bit of talk in Canada as well on the side of ESG reporting. But I believe that this will become a force moving forward for more organizations to look at how they're operating their projects and move those ESG goals ahead. So with this, there are organizations that own large portfolios that are looking at how do they get smarter with the operations side of things and being able to embrace that and build out those digital strategies. Those digital strategies require that integration to happen as part of their design teams so that when the construction teams are involved, they can actually fully do that integration and get that smart building in the end. Now, with this, I want to mention slightly on the side is the fact that I also believe that within design practices, that there is an opportunity to also, once the buildings are designed, to start to monitor them and develop relationships with clients to be able to monitor how the project operates. Things such as within the architecture practices, putting out AIA 2030 commitments, great. We want to reduce our carbon in how we design our projects, but how do they actually operate? How do we actually know that they're actually moving ahead and that they are moving that way? Having that actual feedback loop into the design industry, once there is more smart buildings and building up of data of how they actually operate, that data can actually start to be fed into the process and actually be built off of to improve and leverage as part of the next designs moving forward. Now with this, you might say, wait, Krigh, you mentioned a bunch of stuff about smart buildings. A lot of that seems to be some of the stuff we talked about when it comes to digital twins. And I think that for this, really when I got into understanding, I was a BIM guy. I started understanding digital twins. I started talking to a lot more people in the building intelligence side of things and smart buildings. And really what I started to understand is how these two relate. And I think that they do relate, but it's a bit of an evolution thing. And I think with any of these technologies, there's a maturity that's happening. So really, up until now, we've been talking about BIM for quite a few years. But when it comes to the owner-operator side of things, really the non-graphical data, the stuff that lives in spreadsheets, model numbers, location, room numbers, warranty information, all this sort of stuff is the stuff that's been important because it feeds into the building automation system. But there is this question about, and it continues to come up about, but we've got these 3D models, what about them? And okay, we know we've been using CAD plans and stuff like that for years, so we don't necessarily have the desire yet to jump into using Revit for facilities management, but there is something to be said about what can you do with a 3D model when you incorporate it. And it really starts to speak to the vision. And this is where, if you start to think about where this is all going, buildings are complex. They're made up of all the building systems, the people in them and how they're using them, and the environment around. And if we really want to understand, if we really want to get efficient with what's happening inside our buildings, we have to understand it holistically. So we have to understand all of that information about how it's running and how it's being used. We have to catalog what's happening right now, but we have to know what's happening in the past. And we want to be able to access that information anywhere, but we also want to be able to understand it spatially. And why spatially? Well, how do we do this? Well, we create basically, and if you sort of think about the process of this, you create a virtual copy of what's out there in the real world, or you use a BIM model that was part of the design process. And then you, as we've sort of seen from the smart building side of things, have all sorts of connected systems within that building. If you start to connect the two, if you start to bring it together, if the system starts to understand the relationship of where all the different equipment is, how it relates to each other, you track and monitor everything because you want to be able to analyze, simulate, and automate. And so it's about creating a data stack that looks like this. And I think that, digital twins are not that hard to understand, but the problem, as I said with buzzwords, is they get muddled because we always think of them as, okay, we're going to leave BIM behind. And there's so many people that don't necessarily like the word BIM anymore because they think of it as the past, but the reality is BIM is part of this process. We're building on it. It's becoming part of that stack. And so if we understand that and how it's evolving, you start to understand thinking about things like when you start to talk to people in the building intelligence community and the fact that horizontal architecture of aggregating everything, well, if you just bring a 3D model into that process and incorporate it into that data stack, you effectively are starting to head down that, what everyone seems to refer to as a digital twin, is that you're trying to aggregate all the data, but you're trying to use it against use cases. And I'll talk to that about specifically. But I think the piece that really got it for me, and the piece that I hope to share with you about what really sets digital twins apart, that really I understood at one point, it's the fact that somebody said, well, think about it this way. Think about it if you had a system that operated, it understood everything about the way that building was operating, and it had a relationship with what's happening out there in the real world. So everything that's happening out in the real world as people move through the building, it understands the flow of people. If it has different systems operating, it understands those. But if you could take a copy and paste of that off to the side and say, okay, now I want to tweak this, I want to adjust it, and you sit there and you play with it, or you apply AI and you actually say, now start to run through different iterations and test the system out, and it's trying to find better efficiencies that then you can apply out in the real world and implement and see whether or not you got it right. And if you got it right, our buildings should operate more efficiently and be able to understand and optimize themselves. And that's really the vision of where this is going when it comes to digital twins. That's why we want the digital version of what's out there in the real world, is to optimize it and understand it. But you can only really do that by virtually building what's out there in the real world and making that connection. So where is this going? Okay, the first thing I'm going to say is, when I presented the idea of, well, what about 3D models for facilities management? Somebody in the Nexus community said, as long as it's not like that scene in Jurassic Park where they want to lock the doors and they have to fly through a 3D model to do it. And I think that this sums it up well, is that right now there's a lot of buzz in our industry about digital twins, but the reality of it is that people don't want to fly through 3D models in order to access their data when a list of doors probably would have done it. That said, there is a lot of power to having that 3D. And the two examples that I want to sort of point out that I think it does have a lot of power, and I think building on top of what you saw on the smart building side of things, is for people that are working in remote situations, that which could be a remote, on the other side of the continent or on the other side of a campus from a building, is being able to visually see it and understand it. Much better than seeing a list of doors is one thing. Understanding that if there's a leak detection, being able to understand the relationship of what equipment is around it. That's one side of things. The other side of things, the example by Howden, PTC, and Microsoft, if you haven't seen this video, it's a bit old, but at the same time, they show an example of putting on a HoloLens and walking into a mechanical room and being able to see what's happening with the equipment there. That can only happen if the digital model and the readouts of everything can map itself onto a 3D model and then onto the real world. This is the power of a digital twin, and you can't get that without that incorporation of the 3D model and the spatial relationship of everything. So I think that, yes, okay, we're not all walking around with HoloLens at this point, but this is the reality of where we want to go. The reality is when you talk to most people in the community, though, they're not at that point. They really aren't interested in the graphical side of things yet. Not that they shouldn't be, but it's just the fact that when a lot of systems right now are much more focused on just getting the basic non-graphical information into building automation systems and getting that relationship built and getting your documentation incorporated into it as well. So still looking at how do we pull the right information? How do we get this from different data sources, pull it into one place and be able to leverage it? It's still that aspiration of having that properly defined information requirements so that you can get the information deliverables of understanding that from the design teams of how many units have you got, where are their locations, from the construction team of pulling the exact model numbers and incorporating that in and incorporating it into your operations and getting the operations teams up to speed on using these as a more advanced system. And the way that I would sort of describe this is it's the more recent conversations that I've had with owners and operators on this side of things, it felt like when we first started looking at Revit and BIM in 2010 and started using it on projects, it felt like we were this wave coming from design moving forward. And I'm sure a lot of you on the construction side have felt the same way. Is it feels like we're sitting there going, can we, would you like to use the model for facilities management? And everyone said, no, I just need a set of CAD plans. It's fine, right? And then we'd park the Revit file and archive it. But the reality seems to be more these days that because that influence of the smart building side of things, that we're starting to find more data deliverables, especially when it comes to healthcare projects. But on the other side of things is that as the technology evolves, as we're starting to see more building automation systems start to incorporate 3D models and buy different, we've seen merging of different vendors. An example would be Siemens and Ecodomus as just one example. You're also starting to see different vendors such as you've heard from Bentley up here, Autodesk as well, as different solutions coming out because we know that the 3D models have power. We just know that they are right now, it seems to be a second priority behind just improving the general building operations. So with that in mind, in the last little bit, I'm going to sort of talk about the relationship of how these different pieces come together. And I think that for me, each one of these sessions could be its own 45-minute talk. But I think that they're having sort of a knock-on effect between the different pieces. Because if you kind of think about the way we think about the information flow, so you think about the way we've been thinking about data flowing from the BIM process into the operations, is it happening? Yeah, it's getting better and whatnot. But I think that some of these technologies will actually act as catalysts and start to improve that flow. Starting with the fact that, as I mentioned, the ESG, if we really start to get to the point where projects need to report and understand, if you kind of think about it, a portfolio owner that owns and operates, 100 different buildings across the country, having to be able to understand how much carbon they're actually generating and being able to then say, okay, we also want to look at reducing that. This is going to incorporate a lot more smart technology on that side of things. That being a driving factor for increasing our smart buildings in IoT. With that, and it was mentioned here earlier, the old quote, data is the new oil. So there's one distinct problem with this. Oil is being depleted. Data is not. Data is only increasing. And as we get more and more systems, the only way we can really actually handle and really get to terms with how all of this data, we can't just suddenly hire, 1,000 more people to look at Excel spreadsheets. Really, this starts to look at how do we actually analyze it. And really, the new machine learning side of things really starts to lend a hand on this side of things, because you can give it lots of data and it can start to digest and understand it. And so I think that as time goes on, we're going to see that start to propel our use of smart buildings as well. So with this, in order to get both of these achieved, digital strategies, I think that this is something that we've been talking about BIM requirements for years, but I think that the whole digital strategy side of things is another side of that, is how do you actually have those digital requirements as part of a project? And the other side of things is having that developed well up front, well before there's a project on the table. I know of projects right now that they've said, yes, we've got smart buildings consultants working on developing this as a smart project. Meanwhile, the entire building is being designed around them. Whereas really the systems should have been decided, and exactly the infrastructure of the digital system should have been picked out and developed before they actually started on the physical envelope of the building. And so I think that as time goes on, those strategies will be developed more upfront, because what they will lead to is a more integrated design. As I said, I think that this is something that you'll start to see much more of within the service offering of different design practices, and the incorporation of, call it what you want. Everyone seems to brand it slightly differently, but that idea of the integration of intelligent design, smart buildings, consultancy, whatever you want, which leads to the integration being done as part of master systems integration. And of course, with this, the desire to move to digital twins. It's that idea that as more and more buildings start to incorporate smart building, more advanced building automation systems, those systems will also start to evolve to include that 3D element of it, as well as, even if you don't define the 3D element as part of it, if you want to define it in any way, that holistic understanding of a digital twin is a more advanced smart building in a way. So with this, it comes back on itself, because really, if you want to start to incorporate 3D models and digital twins into your process, it has to come with proper BIM requirements. And I think about, if you sort of read through things like ISO 19650, it's a great standard. I actually really love the concept of it, but it really seems to almost focus on sort of a incorporation into building automation systems and CAFM. It doesn't really speak to that next evolution of incorporating it into digital twins, which is really where this all needs to go, if you kind of think of it as that high-level advanced movement. With this, as I mentioned, you also have the ability for design teams to possibly have a new data source for understanding the operations of the buildings. I think that this is something that, as we start to understand, that whole operations side of things, if you're at a design practice, I think that this is something that you really want to know about, is how well do your projects perform out there? One of the things that I'd put as a bit of a challenge to any design practice is you probably want to understand how well your projects are performing before your clients start to do it themselves. Because if you think about it, one of the things that I batted around before is, what happens if a large portfolio owner actually starts to say, okay, let's look at the carbon intensity of our different projects and how well they perform. Now let's also, in that catalog, tag which design practices designed them, right? There's all sorts of things in this industry where, as we start to aggregate that data, we'll start to understand our projects better. But we really, if we want to be on the forefront, have to understand how our projects are operating. And then from that, we can also learn and get feedback. And I have actually been on projects where we've gotten access afterwards to understand, okay, it was a net zero design building. Now, how is it actually operating? Is it net zero? Is it actually operating this way? And with all this, as you can see, we're adding more and more complexity to what we do. And I think that the machine learning and AI side of things is going to grow as different design tools are being incorporated, because of the fact that we just can't handle more and more things happening unless we've got tools that become more and more powerful. So whether it becomes the automated workflow of design that actually uses hard calculative computational design, but is more powerful and does things that are boring, like a parking layout, or, that sort of like monotonous tasks of, dimensioning things. But if we can take that away and start to focus on other things, it gives us more of an advantage to move forward and be able to focus on more important tasks, such as reducing the carbon within our projects. So I know that was a lot, but I hope that kind of spells out for you how I'm starting to see some of these things relating and starting to propel themselves off of each other. And that I think that there's a lot more things that can change within our industry, but I also kind of feel like this is a bit more of some of the things that are coming in the next wave as we move forward. So with that concludes my talk. Thank you very much. And if you have any questions, we can do some Q&A, as well as feel free to reach out afterwards. My email address is up on the board. Any questions?
Yeah, great presentation. Thank you so much. I'm Nico from Carleton University Studio in Paraguay. And we're working on a prototype for kind of digital twin actually. And we're basing, we are in Congress of open standards, and one of the standards that we look a lot is the TCP. So you mentioned it in your last slide, pretty much saying that it's not sufficient for achieving kind of like this digital twin goals. Do you have any suggestion of how we can complement this standard in order to come up with a language?
And I should clarify, the 19650, I think, is a good standard in the sense of kind of, I think when you read through it, it's more the fact that it feels like the language within it was aimed at much more of kind of that sort of baseline facilities management. But one of the things that I've given talks on previously is the idea that if you actually look at the basic philosophy of what it's trying to achieve, that it's actually still possible to use it to deliver a digital twin. It's just, if you read through the documentation, it doesn't necessarily talk about digital twins, but when you really get down to it, that advancement towards something that is much more advanced and being able to like incorporate the 3D model into the whole operations and smart building side of things, I think that you can still take the same philosophy and use it. So I would definitely still advocate for 19650. I just think it's one of those ones that, as I've always sort of said with it, if it's one of those ones that it's a very text heavy, hard to read sometimes kind of thing, but if you really peel it back and get to the philosophy of what it's trying to get to, I think it definitely does help our industry move forward. So it can be used for digital twins. Yeah. It just maybe doesn't have it in the language.
No, perfect. No, I understand that you support it, but is there any other ISO standard that will complement?
You mean like the ones that are specifically focused on digital twins?
Absolutely, that you.
I don't know of any specific ones. I do know that there's been talk about it in general, kind of thing. But I know that I've been mostly following over the past few years the development of BIM Level 2 into ISO 19650. Mm-hmm. So I don't know that maybe in sort of early stages of development on that side of things, but I would imagine, yes, it's going to emerge.
Thanks so much.
No problem. Okay, thank you.